kind of mixture problem, but here we're dealing with uniform motion problems, so really that just deals with speed equals distance over time, but instead of speed they use rate. And then depending on what we're trying to solve here, we could be solving for distance, we can rewrite it, or like our example, we're actually solving for time. Because usually if you're going the same way, so if it takes me so long to travel to my work and then it takes me a different way, same time travel to my work, the distance is equal the same, so then I can put rate times time the first way equals rate times time the second way, right? And then I can solve for whichever one I want to solve for. Okay, so here we have this colony of bats that go underneath this bridge in Texas, and it's 1.5 million birds. That number really doesn't matter to us in this problem. It's just set in the scenario. And they travel an average of 25 miles per hour. So their rate equals 25 miles per hour. Suppose it takes one bat to fly 5 hours. Okay, so time would equal distance over rate. And it takes them 121 miles to go round trip. So that's 2 ways, right? So if we divide that by 2, we get 60.9. And then assume, so that's would be the distance. Assume that the bat flew one way at a constant speed, determine the wind, the speed of the wind. So that means at the rate, he went with the wind, so we can add W for wind, and then we can take the 25 minus W when he goes against the wind, right? So we have 2 rates, and our distances is he's going one way, right, at a distance, divided by the rate, which equal his time. And then we add that going the way back over his rate against the wind, and that's going to equal his total time, right? This time, because this is some t1 and this is some t2, and it's going to equal our total time t, right? Which is 5 hours. So now I can set up this equation here, this rational equation here. And so we can find the LCD, and the LCD is just these 2 denominators, right? Because this denominator is 1. So the LCD is just 25 plus W times 25 minus W. So when we multiply this side by it, that cancels out. We just get 25 minus W times 60.9. So if I distribute that, 60.9 times 25 equals 1522.5, and then minus 60.9 W. And here, this one's going to cancel out, so I get 25 plus W times the 60.9, which is going to equal, again, positive 1522.5 plus 60.9 W. And then that equals 5 times both of those times 25 minus W. So FOIL that out, and we get 25 times 25, which is 625, and 625 times 5 equals 3125, and then we get it conjugate, right? So the middle is going to drop out, so then we just have minus W squared times 5, and that would just be a 5W squared. Okay, so these are going to cancel out, right? And then we have 1522.5 plus 1522.5, so we have 3,445 equals 3125 minus 5W squared. So here, this quadratic, we could set it equal to 0, but we don't have to because we're just don't have a C, right? So it's better just to move this one over. So I don't really need to set this equal to 0, but I'm just going to move this smaller number over to get the 100 and what, 31 minus 3,045, 80. So we just get 80 minus 5W. So here I don't really want to set it to equal to 0. So I can just add 5W to both sides. 5W squared. 5W squared equals 80. 80 divided by 5. Divided by 5, 16. 16 square root, and we get W equals 4 and W equals negative 4. Now, can I have a negative wind speed? Not really, unless I'm just talking about direction. So really, Just the positive one will do here. And we can check those two, make sure our denominators, we don't have 25, right? Because we have 25, we would divide by 0 here. So there's no extraneous solution here. It's just wind can't be negative unless you're talking about direction. But we'll just go with wind speed of 4 miles per hour.